Welcome to the DIY Honda Garage channel. The vehicle model Honda Accord 2023 Plus may encounter a DTC, specifically P055D, which indicates a situation where the rocker arm oil pressure sensor circuit is showing high voltage. This diagnostic trouble code alerts the vehicle's powertrain control module, PCM, that the output voltage from the rocker arm oil pressure sensor has exceeded a predetermined normal range. This sensor plays an essential role in monitoring the oil pressure that governs the functioning of the rocker arms in relation to engine oil distribution. If the oil pressure is too high, it may lead to incorrect functioning of the engine's hydraulic mechanisms, potentially resulting in decreased engine performance or damage. The sensor is typically located near the rocker arms and is connected to the vehicle's wiring harness that runs into the PCM, making it vital for proper operation. The rocker arm oil pressure sensor is a crucial component responsible for monitoring the hydraulic pressure that operates the rocker arms in an engine. It is designed to relay the pressure level to the powertrain control module, PCM, which then processes the information to optimize engine performance. The exact location of this sensor is typically found near the rocker arms, making it easily accessible for inspection and testing. When the output voltage from this sensor surpasses the typical threshold, as specified in the diagnostic guidelines, it indicates a malfunction. In this case, the PCM stores the fault code P055D, indicating high voltage from the sensor. This fault can lead to serious engine performance issues, warranting prompt troubleshooting to identify and correct the underlying problem. There are several potential causes for the appearance of DTC P055D. One common issue could be a faulty rocker arm oil pressure sensor itself, which may exhibit high output voltage due to internal failure. Another possible cause could be related to wiring issues, such as damaged or frayed wires in the connection between the sensor and the PCM, leading to incorrect voltage readings. Furthermore, a malfunction or failure within the PCM could also be responsible for interpreting sensor data inaccurately. It is essential to systematically investigate each of these components to determine the root cause of the high voltage reading. Diagnostic procedures outlined in this manual will guide the technician through a comprehensive check of these possibilities. When the P557 code is triggered, drivers may notice a range of symptoms that can indicate underlying issues with the rocker arm oil pressure sensor. One of the most common symptoms is poor engine performance. The vehicle may struggle to accelerate or exhibit rough idling due to incorrect engine oil pressure readings. Additionally, the presence of a check engine light on the dashboard is a clear indicator of this DTC occurring. Unusual noises emanating from the engine are also a frequent complaint, which might stem from improper oil distribution resulting from the faulty sensor. In some cases, further complications may arise, such as stalling or reduced fuel efficiency. Recognizing these warning signs early can assist in prompt diagnosis and repair. The first step in troubleshooting DTC P055D involves turning the vehicle's ignition to the on mode, which activates the vehicle's electrical systems without starting the engine. The next action requires using the Honda Diagnostic System, HDS, to check the voltage output from the rocker arm oil pressure sensor. Specifically, you will monitor the voltage value displayed for the sensor. If this value exceeds 4.79 volts, this confirms that the failure is indeed replicated. It is essential to accurately interpret these readings, as a voltage higher than the specified limit clearly indicates an anomaly within the system. Should the sensor output remain within acceptable parameters, focusing will then shift towards inspecting the wiring and connections. The second step in the troubleshooting process requires disconnecting the rocker arm oil pressure sensor connector, which is typically a 3-pin connector. Following this, terminals number 1 and number 2 of the sensor connector should be temporarily shorted together using a jumper wire. This action mimics a normal operating condition for the sensor and allows for further verification of the system integrity. Subsequently, turn on the ignition again to the on mode and recheck the HDS for the voltage output from the rocker arm oil pressure sensor. If the recorded voltage is less than 4.79 volts during this test, it suggests that the sensor is functioning correctly, and the issue may lie elsewhere, such as within the wiring or the PCM itself. In the third step, the focus shifts to conducting an open wire inspection specifically for the wires connected to the rocker arm oil pressure sensor. Ensure that the rocker arm oil pressure sensor is disconnected states, along with disconnecting the PCM connector. The next action is to perform a systematic inspection of the SG2 and P-oil2 circuits. Utilize a multimeter to check the resistance. In normal conditions, the resistance should be less than 1 ohm for both circuits. Resistance readings indicating an open wire condition or significantly higher than the acceptable limit point towards wiring issues or poor connections, which could disrupt the flow of necessary voltage signals. Consistently achieving low resistance readings signifies that these circuits are functioning correctly. The final step in the troubleshooting process involves inspecting the powertrain control module, PCM, once previous inspections of the rocker arm oil pressure sensor and wiring have yielded normal results. The PCM is the vehicle's main computer that interprets the data it receives from various sensors. And a malfunction at this level can lead to incorrect readings being processed. If all other components have been verified and found operational, a comprehensive evaluation of the PCM should be conducted to determine its functionality. This can include software diagnostics as well as physical inspections that assess condition. Should the PCM be determined defective, it will need to be replaced to restore proper communication and functionality within the engine management system. After completing all necessary repairs related to DTC P055D, it is essential to clear the diagnostic trouble code from the vehicle system. This action resets the system and removes previously stored error codes, allowing for a fresh assessment of the vehicle's performance. Following this, conducting a test drive is an important step to confirm that the repairs were successful and that the vehicle is functioning properly without reactivating the code. During the test drive, closely monitor the vehicle's performance, taking note of any irregularities or warning lights reappearing. Should the DTC return or exhibit new codes, further investigation is warranted to ensure all components have been accurately addressed. To minimize the likelihood of encountering DTC P055D in the future, implementing a series of preventive maintenance measures is highly advisable. Regular oil changes are crucial, as they maintain engine health and optimal performance, ensuring that the hydraulic pressure levels remain within the required specifications for the rocker arm system. Additionally, routinely inspecting wiring connections related to the rocker arm oil pressure sensor can help identify any wear or potential issues before they lead to significant problems. Lastly, periodic checks of the sensor itself, including verifying its output voltage during regular service appointments, can be an effective approach in detecting early signs of failure. These proactive steps can greatly enhance the longevity and reliability of the engine's performance. In summary, the DTC P055D signals an abnormal condition related to the rocker arm oil pressure sensor circuit, specifically indicating high voltage output. Correctly diagnosing this issue is critical, as it can adversely affect engine performance and longevity. It is imperative to methodically follow the outlined troubleshooting steps, starting from checking the sensor voltage to inspecting wiring integrity, and, if necessary, evaluating the PCM. Understanding the role of each component, along with routinely performing preventive maintenance, significantly reduces the risk of similar issues in the future. This proactive approach ensures smoother operations and a more reliable vehicle performance. Please like and subscribe to the channel. See you next time.